In problem number 6, it is giving you a function. So here's your quadratic function, and it's going to ask you for the x-intercepts, the y-intercept, the vertex, and then they want you to rewrite it in a different form, the vertex form. So we want to remember the 3 forms we've done so far, which is vertex form, standard form, and factored form. This one that they gave you is already in factored form, which means that we can easily find the x-intercepts. The x-intercepts is when the function is equal to 0. So we want to know what makes each of these factors equal to 0. The first one's going to be 3, because 3 minus 3 gives you 0. And then the second one is going to be 5, because 5 minus 5 is going to give you 0. This means we already know our 2 x-intercepts. One is at 3, 0, and 5, 0. I always think it's nice to have a visual for these quadratics when you're finding these important parts. So I'm just going to make a drawing. Make that straighter. So we got our y-axis, and then we have our x and y. And we've got a 0 at 3 and a 0 at 5. 1, 2, 3, 4, 5. So one's at 3 and 5. Part B asks us to find the y-intercept. If this function was in standard form, we could easily find the y-intercept, but it's in factored form. So we just want to go ahead and convert it into standard form. And by doing that, we're going to have to do the box method. If you're a fan of the box method, if not, you can use distribution. So we want to turn this into standard form. So I'm going to go off to the side and set up my box. And I'm going to put x minus 3 on top, x minus 5 on the side. Multiply to get in. So x times x is x squared. X times is negative 3x, negative 5x, and then positive 15. So when we go and combine like terms, we have x squared minus 8x plus 15. Now we have the same quadratic function in standard form, and we know what our y-intercept is, which occurs at 0, 15. So somewhere all the way up high at 15, we have our y-intercept. Now to find the vertex point, we want to remember that the vertex is always in the middle of our x-intercept. So if I go back to my graph over here, the middle of 3 and 5 is going to be 4. We just need to know, is it 4, 1, 4, negative 1, 4, negative 2? It can't be 4, 1 because we know that this parabola has to face up. So in order to figure out where our vertex occurs at, 4, something, we need to plug it back into the function. You could plug it back into standard form, or probably easier to plug it back into the factored form. So when I plug it back in, I'm going to get y equals, I'm going to put 4 in for the x, and 4 in for that x, and 4 minus 3 is 1, 4 minus 5 is negative 1. 1 times negative 1 is going to give you negative 1. Now I know exactly where my vertex occurs at, 4, negative 1. And I pretty much have everything I need to get a good visual of this parabola. So it's opening up, crosses at the 5 and the 3, and crosses all the way up in the y-axis at 15. So part D, you have all the information you need to put it into vertex form. And what do you need? Most importantly, is that vertex point. That vertex point occurs at 4, negative 1. So vertex, at 4, comma, -1. So when I write it in vertex form, we're going to put the x coordinate inside but flip it, so x minus 4 squared, and then the y coordinate on the outside. And there's our vertex form. And if you want to double check and make sure you did this correctly, probably the easiest way is to put all 3 of the functions into your calculator. So the factored form, standard form, and vertex form. Put them into y equals and make sure you get the same table of values or you get the same parabola when you graph it.